Hello everyone. Today I want to show you how to trace Primavera P6 Professional connected to an Oracle database. And we're going to use the Oracle DBMS support package to actually trace our session along with the wait events and the bind variables. I prefer this method especially because you can use the wait events to diagnose performance issues and identify the exact culprit, if it's the database or the client or maybe the network in between. So first of all, by default, the Oracle database is not enabled for tracing with wait events. So for this, we're gonna need to actually enable the DBMS support package. So for this, I'm going to use an Oracle 12c database, and I'm going to go to my DB home in the RDBMS folder and admin. And in the admin folder, I'm going to search for the following package: RDBMSS RDBMSS. Should be right here. Let me see. It should be DBMSS, sorry, UP. DBMSS UPP. And once you find the SQL file, then I'm going to copy. I'm going to hold down Shift and copy as path, just so I can use it later. And next, I'm going to actually open up SQL Plus, and I'm going to connect as a sysdba user. So SQL Plus sys/pmdb as sysdba. So I'm using SQL Plus to connect as the sys user to the PMDB instance. Notice that this will be different for you depending on the instance name that you have as a sysdba. Okay, and let's see. So PMDB, let's see. PMDB should be up and running. Let's try the connection again. Let me check real quick the services. The service is up, but for some reason my database is not responding. So, oh yeah, and this is why it's not responding, because I did a mistake. I shouldn't have connected /PMDB at PMDB. So PMDB is my database instance. And let me enter my password, and I'm connected. Once you're connected as a sysdba user, keep that in mind, I'm going to execute the SQL script that enables the DBMS support package. And notice that the package was created and the package body was created as well. If you're going to execute the script as a DBA user, for example, the package body will fail to be compiled. So keep that in mind when performing this. And now that we enable the package, the next thing that we want to do is actually identify the a serial ID and the serial, so the SID and serial for our connection. And we're going to use a simple select query to do this. And this identifies the SID and the serial number along with the OS user, the machine name, and the schema name, in case you might have multiple schemas and multiple clients connecting to the same database. This won't be the case for me. And if I execute this query at the moment, it shouldn't return any records since I don't have a connection to the database yet. Now, I'm going to go to P6 Professional and actually start it up. I'm using a 64-bit P6 Professional that's connecting to the database. And notice or keep in mind that in P6 Professional, to connect to an Oracle database, it uses a TNS connection using the Oracle client. Actually, it requires the Oracle client to connect. And that's why we're able to trace this session. So let me type the password in, and I'm going to connect real quick. And once I'm connected, if I execute the query that we ran last time, just press tab and enter, you'll see that I get a serial number and a seed. If you're gonna use the query with SQL Developer or Toad or any other client, you'll notice that this will be much better formatted. But for my purposes, this is more than enough. So once we have identified our SID and serial number, I'm going to go in and actually enable the trace. So for this, I need to type in the SID and the serial number 7934, and I'm executing it with wait events enabled and with bind variables. Oh, okay, and this started the tracing procedure. Now we can go to the P6 application and actually start our operation. For example, I'm interested in opening a project. And for this, I'm just selecting a project and go open. That's absolutely everything that I want to trace at the moment. This is just for demo purposes. So once you have executed your required operations in the application and are happy with them, you can go back into SQL Plus and stop the trace. And I'm going to use a similar procedure in the DBMS support package named stop trace in session, and I'm going to execute it. And now our trace should be stopped. Now, considering that I'm using an Oracle 12c database, in order to find out where the traces are stored by default, I'm going to use the following query. So select star from view diagnostic info where name like diagnostic trace. And let's see what this returns for us. I should have it in Oracle DB12C, diagnostic, RDBMS, PMDB, PMDB trace. Just going to copy it real quick from here just so I don't navigate to it by hand. And if we go into this location, this is where our trace will pop up. Now, the trace might take a little while to be created. And keep in mind that when it will be created, it should have a much larger size than all the default files. It will be a .trc file. So it might take a minute or two. Note that the name of the file is randomly generated by the system. and my file finally got created. I went in and redid one more try just to be sure. But once you have the file created, you can just copy it from the location where it gets created and take it to someplace else, just because that's a temporary location. And let's say in here, traces, and I'm gonna paste it. And let's navigate in the command prompt to here. And now I'm going to use the tkprof tool to actually convert. So if I were to open up this, file at the moment, this is really not understandable. So what we're gonna do is use tkprof to convert it from its default language to what it should to a more understandable language. So for this, we're gonna specify the name of the file, and out.txt will be the output. And now if I were to open up this tkprof file, I have all the queries that were executed, including the wait events and the bind variables. So for example, it does select one from dual where DBS object and D calls equals S calls. So and as you can see, we have a series of system events here as well. So I'm not really interested in these. Let me do the trace conversion again, but this time I'm gonna say sys no. And now if I open up the file, I shouldn't see anything um, regarding. So now if I open up the file, we shouldn't see anything regarding system messages or system queries such as the select from dual and so on. So for example, in here we have select WBS ID from project WBS, where WBS ID equals this variable and this actual number. And of course, this is an unsorted, excuse me, this is an unsorted file. If we want, we can also sort the file using tkprof. So for this, I'm going to go to tkprof just to show you the options. Actually, let me execute it. Okay, so without the help, we have sort options, and we can select one or multiple options to sort from, such as CPU wait events, memory wait events. Um, One of my preferred sorting option is XLA, which is elapsed time. So let's try this again with sort equal XLA. And of course, you could do comma and other options in here as well. Just if you have queries with the same amount of elapsed time, or you can change the main sorting option. And now that I've re-executed, we should see if I'm gonna go to home. The first thing we're seeing. So select count, select from gateway deployment where update. So this is a Primavera statement. Not interested, and then the longest elapsed time was actually inserting into the DLT resource table. And let's see, this took about 0.03 seconds, and we see exactly what the query did. It loaded the table, it sorted, and then the entire all the operation it did for the other joins that it has in this query, because this is a pretty complex query that the system is using. And of course, we can also see weighted events. These are external events either to the database or to the applications that are communicating. And we can see that, for example, DB file sequential reads are used. They don't really take up much time since these are returning quite a small amount of data in this scenario, but in bigger environments, they could take a lot more out of it. And of course, if you go to the very end, you'll get a summary of everything that was captured, including total events. For example, um, it took 377 milliseconds in this entire log. Overall totals for recursive statements, disk and file operations. This is for diagnosing the actual database, and of course all the extra information that was caught in this trace file. Well, thank you very much for your time, and I hope this was useful. Bye bye.